Okay, so you need to go to your 2122 notes handout from yesterday. And this is where we left off. We'd gotten all the way through all the different rules and ways that it works, talking about being differentiable, meaning you can take a derivative, and then being continuous. As we scroll down then, this kind of goes back to what we started yesterday with, looking at the limit definition of derivative. And this in particular is our first day definition. So way back when we started 2.1, day 1, we gave you this limit definition of a derivative. Well, now you should start to see some parallels. Like, for example, they both have delta x going to 0. They have this something plus delta x showing up. And they have this delta x in the bottom showing up. Well, so then we've seen some parallels. The reason that you need to try to recognize this as a derivative is because if you don't, having the sign of something plus something else, or the cosine of something plus something else, that requires trig identities that you may or may not remember about how to split them up and how to rationalize and clean all this stuff up. It's complicated, but AP is not really wanting you to do that. They're wanting you to look at this problem and say, I recognize that limit. That's a limit definition of a derivative. Well, now I know derivative rules, and so instead of actually finding the limit, I can just find the derivative. So we need to talk about what this represents and how you do that. Typically, if you kind of notice, here is your function. Well, this part right here at first is usually your function. Okay. Then usually you're trying to take a look at where you want to evaluate the derivative, and this is typically the number that's going to help you with that, because this is how allowing you to see what x we're plugging in. So this is usually the x that we want. And then the last portion, the number, this is where you need to check to see if it turns out to be f of whatever the x number that you found in red was. And I agree at first this may not make sense, and that's okay. We're going to break it down a piece at a time. Okay? At first, if you can just recognize the parallels, like, hey, this delta x going to 0, the delta x on the bottom, the something plus delta x, that should then trigger your mind to think about derivative, limit definition of derivative. And then now you have to try to match up all the things. So what I'm trying to tell you to look at here and consider, what if we consider the function f of x equals sine of x, because I see them talking about sine of something plus delta x. Then, what if I had you check the limit definition of f prime? F prime of x would be the limit, and they're doing delta x, so as delta x goes to 0, of f of x plus delta x. Well, that would be sine of x plus delta x. Minus f of x, well, that would be sine of x all over delta x. Well, now try to compare these two. Are they the same? Well, no, they're not exactly the same, but I see some parallels. Then if I come back and I try to replace these x's with what I told you, usually this is the x you're interested in. What if I try to replace that with pi over 4? And I try to replace that with pi over 4. Then I would also have to come over here and replace this with pi over 4. But what if we tried that? Okay, well, so then I have to evaluate, check and see if this last part is coming out to be right. What is sine of pi over 4? Sine of pi over 4 is square root of 2 over 2. Yes, that is the number that I'm seeing up here. So this actually is matching up. When it's asking me what does this represent, what this represents, I'm trying to see what kind of color I'm going to do. Let's just go back to the blue. This represents f prime of pi over 4 for f of x equaling sine of x. Okay, well then that also means lots of different things. So there are different interpretations. That then also means the slope, right? Slope of tangent line or slope of the graph. So you could say slope of f of x equals sine of x at x equals pi over 4. Or the slope of the tangent line to f of x equals sine of x at x equals pi over 4. So to just answer their first question as far as what it represents, that's what it represents. Then, if time to talk about evaluating, the reason why that's helpful is because you might see this limit question on an AP test and they say find this limit, and you might look at it and say, well, that's awful, I don't remember my trig identities, I don't know how to break this apart, I don't know how to find that limit, and it's going to take me forever and I don't have that time. Well, hopefully you're going to see this and look at it and go, oh, wait a second, that's asking for f prime because I recognize the notation. F of x is sine of x because I recognize that function. My x value that they're interested in is pi over 4 because I've checked the pi over 4 matching up, and I've also checked the value of sine of pi over 4. Well, if so, then you can say, hey, this limit is equal to, well, how do you take f prime if f is sine of x? If f is sine of x, then f prime of x, derivative of sine, is cosine. Then f prime of pi over 4 is cosine of pi over 4. And so if you wanted to show some work, it would be that that limit equals cosine of pi over 4, and cosine of pi over 4 is radical 2 over 2. So you could evaluate that limit really, really quickly, as long as you recognize that that limit is really just asking you to find a derivative. So that's where the value of these questions about what it represents comes into play. Okay, so you want to try to break this down, and you may want to pause the video and actually try it on your own. With the last example, can you try to use what was there to help you match this one up? And then come back when you want to go over it. Okay. So we always look at this first portion to try to figure out our function. And then we look at whatever is added to the h to try to figure out the x that we're interested in. So I'm taking a look, and I think the structure of my function that I notice is that I'm going to try the function 3 because I see a 3 out in front. And then I'm going to try x to the 1/3. Okay? Because then if I want to check and confirm, f prime of x would be the limit as h goes to 0 of f of x plus, in this case, h, minus f of x all over h. Well, so that would be the limit as h goes to 0 of f of x plus h would be 3 times x plus h to the 1/3. That's checking out. And the over h part is checking out. Well, now we have to talk about this last part. I think that my x is supposed to be when x equals 8. I think that's what I'm interested in. So then I need to check if this is f of 8, because this last part tells me I'm supposed to do minus f of x. Then I'm going to go back and I'm going to replace all the x's with 8, hopefully. Hopefully that's going to work out. Okay, well, so if I go back up and I check, what is 3 times 8 to the 1/3. Well, the 1/3 power is the cube root, so 3 times the cube root of 8. And the cube root of 8 is 2. 3 times 2 is 6. Yes, that worked. Yes, f prime of 8 is equal to the limit as h goes to 0 of 3 times 8 plus h to the 1/3 minus 6, because 6 was f of 8 all over h. So then when it says, what is this asking you to find? It's asking you to find f prime of x for f of x equaling 3x to the 1/3 when x is equal to 8. Or it's asking you to find the slope of f of x for that function when x equals 8, just like we talked about before. As far as evaluating, then to evaluate, you would come over and say, okay, if f of x equals 3x to the 1/3, what's f prime of x? F prime of x is 3 times 1/3 times x to the, well, I have to do 1/3 minus 3/3. So x to the negative 2/3. Those 3's cancel and I just get x to the negative 2/3. Then go back to finish it up and plug in f prime of 8. So that would be 8 to the negative 2/3. Do your cleanup. Okay, so that's one of our ideas, is really trying to connect when I see these weird limits that have x plus h or x plus delta x. Check all the parts. Is h going to 0 or delta x going to 0? Do you have h in the bottom or delta x in the bottom? And if so, then you need to recognize those limits as asking you to find derivatives. And you now know how to find derivatives, so you need to do that because that's going to be the most efficient way to solve these problems. Sometimes it's going to be the only way to solve these problems. Okay, I'm actually going to segment this into two pieces. So that's the part about interpreting limits as definitions of derivatives. Then I'm going to segment out and do piecewise derivatives. Oops.